Welcome back students to my YouTube channel. In this video I am going to solve National Level Mathematics Olympiad 2009 paper for class 10th in continuity of previous videos. So let us start with question number 27. A hollow cone is cut by a plane parallel to the base and the upper portion is removed. If the curved surface of the remaining is 8 by 9 of the curved surface of the whole cone, find the ratio of the line segment into which the cone's altitude is divided by the plane. Now in this question we are given there is a cone, suppose this is a cone, and it is cut by a plane into two parts. A smaller cone and the lower portion, this is called frustum in mathematics. So what is he saying? If the curved surface area of the remaining, this portion is, let us suppose that this is whole cone and we denote its area by AW, and the cone of the smaller portion and the area of the smaller portion and area of the frustum. Now what does it says? If the curved surface area of the remaining, that is area of frustum, is 8 by 9 of the curved surface area of whole cone, find the ratio of the line segment into which the cone's altitude is divided by the plane. Suppose this is the altitude and the altitude is h for the whole cone, and for the smaller cone it is h1 and height of frustum be h2. Now the curved surface area of frustum is 8 by 9 of the curved surface area of whole cone. So from here we get the curved surface area of smaller cone will be 1 by 9 of the whole cone. This is 8 by 9, so we subtract this from 1, we get 1 by 9. So the area of the smaller cone is 1 by 9 of the whole cone. Now we know that ratio of the area of the cone, let us see, AS upon AW. Ratio of the area of the two, because these two cones are similar cones, so their ratio will be square of the ratio of their heights. This is capital H. So AS upon AW is 1 by 9, that is equal to H1 upon capital H whole square. So H1 upon capital H will be 1 by 3. So from here we get H is equal to 3H1. That is height of the smaller cone is 1 by 3 times height of the bigger cone. Now this height is sum of the H1 and H2, where H2 is the height of the frustum. So from here we get H2 is equal to 3H1 minus H1, that is H2 equal to 2H1. So the ratio H2 upon H1 is 2, or we can say we have to find the ratio of line segment into which cone's altitude is divided by the plane. So H1 upon H2 will be 1 by 2. So the height is divided in the ratio 1 by ratio 2. So our answer is option D. So this solves question number 27. Now look at question number 28. P and Q are the midpoints of the sides CA and CB respectively of a triangle ABC right angled at C. Then, now I have made this figure already. Let a triangle ABC be such that it is right angled at C. P and Q are the midpoints of CA and CB respectively. I have joined PB and QA. I have joined these. Now we have to find the which option is correct. Option A is 4Q square equal to 4B square plus AC square. Option B is 4BP square equal to 4AC square plus BC square. Option C is 4 of AB square plus AC square equal to 5 BC square, and option D is 4 of AQ square plus BP square equal to 5 AB square. Now here we use the Pythagoras theorem. So according to Pythagoras theorem, in triangle AQC, hypotenuse, that is AQ square, equal to sum of the other two square of other two sides. So it becomes CQ square plus AC square. This is first equation. Similarly, in triangle BCP, we have BP square equal to BC square plus CP square. And in triangle ABC, again using Pythagoras theorem, AB square equal to AC square plus BC square. Now add 1 and 2. Adding 1 and 2. This becomes AQ square plus BP square equal to CQ square plus AC square plus BC square plus CP square. Now AC square plus BC square is AB square. So it becomes AQ square plus BP square equal to, this becomes AC square plus BC square is AB square plus CQ square plus CP square. Now this CQ square plus CP square, look at this. This CQ, this is half of BC. So we can write it as AQ square plus BP square equal to AB square plus CQ is half of BC, that is half BC whole square, plus now CP square. CP is half of AC. So plus half AC whole square. So from here we get AQ square plus BP square equal to AB square plus 1 by 2 whole square is 1 by 4. Take this common, and inside we have BC square plus AC square, which is again AB square. So from here we get AQ square plus BP square equal to AB square plus AB square by 4. Now on solving this, we get AQ square plus BP square equal to 5 by 4 of AB square. So take this 4 to right hand side, left hand side, so it becomes 4 of AQ square plus BP square equal to 5AB square. So this solves this question. This is option number D. So our answer is option D. So I hope you understand this question. Now look at question number 29. If points 3, 3, H0, 0K are collinear, then we have 4 options here. A option is 1 by H plus 1 by K is equal to 1 by 3. 1 by H plus 1 by K is equal to 1 by 2. 1 by H plus 1 by K is equal to 1 by 6. and D option is none of these. So in order to solve this, let us see. Now these points are collinear. So area of triangle formed by these points will be 0. We will use this fact. The formula for area of triangle with 3 vertices x1, y1, x2, y2 and x3, y3. The formula is 1 by 2 mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this should be equal to 0. Now here the points are x1 is equal to 3, y1 is equal to 3, x2 is equal to h, y2 is equal to 0, x3 is equal to 0 and y3 is equal to k. So put these values here. So we get 1 by 2, x1 is 3, y2 is 0, y3 is k plus x2 is h, y3 is k, y1 is 3 and x3 is 0, so whole thing becomes 0. This is equal to 0. So we can say the inside thing of this modulus function must be 0. The inside function must be 0. So we can get minus 3k plus hk minus 3h is equal to 0. Now this you rewrite this. This can be written as hk equal to 3k plus 3h or 3k plus 3h is equal to hk. So divided by hk, it becomes 3 upon h plus 3 upon k is equal to 1. And take this 3 to right hand side. So 1 by h plus 1 by k is equal to 1 by 3. This is the final answer. This is option number A. So this solves this question number 29. Now look at question number 30. It says determine the ratio in which the line 2x plus y minus 4 equal to 0 divides the line segment joining the points A and B. Let these be 2 points A and B. A point is 2 minus 2. B point is 3, 7. We have to find the ratio in which this line, suppose this is the line 2x plus y minus 4 equal to 0 and it divides this AB in the ratio k ratio 1 at point C. Now we have to find this ratio. Now using the formula we have for section formula, what does it say? Points, coordinates of C are, we have this formula. If the line, if a point divides the line in the ratio m1, m2 and the coordinates are x1, y1, x2, y2, so ratio, coordinates of C are m1, x1 plus m2, x2 upon, sorry, m1, x2 plus m2, x1 upon m1 plus m2 and y coordinate is m1, y2 plus m2, y1 upon m1 plus m2. So use this formula here. Coordinates of C will be 3k plus 2 upon k plus 1 and another will be 7k minus 2 upon k plus 1. Now this point C lies on this line 2x plus y minus 4 equal to 0. So it should satisfy this line. So 2 into, in place of x put this value 3k plus 2 upon k plus 1 plus y 7k minus 2 upon k plus 1 minus 4 equal to 0. Now solve this it becomes k plus 1, and above in the numerator we have 6k plus 4 plus 7k minus 2 minus 4k minus 4 equal to 0. Take this k plus 1 in multiplication with minus 4, so we will get this. So numerator should be 0. So simplifying this, 6k minus 4k, 6k plus 7k, 13k minus 4 is 9k. So it becomes 9k, and 4 minus 2 is minus 2, minus 2 minus 4 is minus 2. So 9k is equal to 2, k is equal to 2 by 9. So ratio is 2 by 9 ratio 1, or we can say 2 ratio 9. So our answer is option number B. So this solve question number 30. I hope you find this video useful. So for more videos like this, please subscribe my channel and like and share this video as much as you can. Thank you.